Okay, this is TempleOS 5-minute random code walkthrough episode 87, and I'm your host, Terry Davis. And today, oh no, we are in the header file for everything. Okay, so the file we're in is in the kernel directory. It's called Atom1A. Atom1A has the class and define. There's no actual code in Atom1A. Atom1B and C have externs for functions. Atom1A doesn't have externs for functions. It just has class and pound defines. So I could do a quick run through from the top. It's a lot of code. It's 3,000 lines. So we have some forward definitions for classes. We have integer range defines. I like defines, not enum, because in fact I didn't put enum in my compiler. I just like it because it's simple, and if you can do it in a simple way, why do you want to make it more complicated? That's just one less. Well, anyway, so I have typecasting postfix, not prefix. So this is how you you can enter a 64-bit floating point double constant. You can make it into a float. So you should get familiar with 1.0 is 3 FF0 and then zeros. I like to say if I did a employment test, I might ask somebody to represent a floating point number. Anyway, so what else we have here? So there's my integers have what I call sub-integer access. What I do is, this is kind of like bit fields. I don't have bit fields in my compiler, but what I have is you can tell it a if you don't have a if you make an integer like an I64I, then you can access it as I equals 1, 2, 3, but because it has a I64 is made up of sub-integers, let's say this was 0, 0x0, then you can say I dot u8 sub 1, and that's 1, that's 0x01. Anyway, so there's what I call sub-integers. So the compiler is a little bit different because you tell it what the whole variable is, and then you tell it what the parts of the variable are. So I is intrinsic. So an I8 intrinsic is I just bailed out. I didn't want to save my modified. Anyway, so an I8 intrinsic is then that's the actual internal type. So it's actually not any faster doing this. It should use bit shift, but this actually what it does, if you call a variable, if you access a sub integer, then it no longer uses register variables. So it's actually slower in most cases, which is kind of ironic. Oh well. So I've got complex numbers. I have some various data types, standard, two-dimensional integers. Well, anyway, it's pretty self-explanatory. So I have some intrinsic data types, my ordinary differential equation solver. This is kind of everything that's in the operating system shows up in this header file. Integer software interrupts and stuff, fault interrupts, the flags, that's the system flags. E flags. There's, I think, even though it's 64-bit, you only have 32 bits of system flags. The global descriptor table, that's for setting up protected long mode. Anyway, so this is the format for my binary files. My compiler makes its own binary file type. I have posted on my website a bin rep. If you go into the Terry files on my website, it'll help you see how the binary files are structured. They have a header, and anyway, bin file header, and then they have a table full of externs and imports and exports and stuff. So run levels, it's not very much like Linux. I set a flag when as it completes different stages during boot. Anyway, the local APIC. I don't really remember this stuff very well. Once you do it once, you forget about it after years if you don't touch it. So these are model specific registers. If you want to set the FS segment or GS segment, you actually have to do it with the model specific. EFIR is for changing to, I forget, 64-bit or long, I think it's for 64-bit mode. So, so at one point I had my global variables in separate, but then I bunched them into structures. So now there's a single structure for each group of global variables. When you do a sometimes you do some BIOS. There's the 32-bit BIOS, which is this is for the CPU ID instruction. Returns the registers. Semaphores. It's kind of maybe crappy putting so many diverse things together. These have to go in their own cache line. I don't really do this very carefully, but I think when you use a lock, you're supposed to have everything in a separate cache line. I don't know what happens. I have lock bits that I'm not separating. I have structures with the lock, and I don't really pay much attention. As long as there's no other lock, I think it's okay. Anyway, it's pretty stable. It doesn't crash very often. Anyway, so hash table types. So I defined these are okay, where is the hash table? So this is the base. I have some C++ features. You can inherit or whatever you can have a base class, a single base class. So a source symbol has a hash as a base. These have, my hash table is an array of linked lists. And anyway, it also has, in addition to my hash entries linked to the table, they link to each other so that it's a sparse table. So if you want to quickly go through the list, you can use the next and last circular doubly linked list queue. Anyway, so various hash entries. There's my birds. So the compiler, the compiler uses the hash table, and that's for member variables of classes themselves. It's pretty strange to talk about classes when you're looking at the structure in the compiler for a class, but that's what we're doing. Some of these things. There's a function actually looks like a class, which is that's pretty strange, but oh well. So now we get into the document. I call these doll docs, at least that's what I call them in theory. They have dollar signs. They're not just text, they have sprites. So I have flags for the individual entries, and then we get into flags for the document main structure somewhere. There's the most confusing thing about this is these invert, select, blink, invert, select. So these are bits. I think they're maybe 28, 29, 30, 31. The individual entries have these flags, and then these individual, a lot of different places you see these four grouped together. They have to be in the same location, and anyway, it's kind of not straightforward. You see these are defined in terms of the entry flags. This is the document flag, and then these are the document entry flags. So a document is made up of lines of text, and there's a carriage return on each line, and that's an entry. We can look at the entry types. The entry types, you can have text, new line, soft carriage return. It'll store the cursor location in the file. A tab is a separate entry. Anyway, I better not get into these. I'm going to run out of time. So what else do we have? Let's go a little faster. So we have the document structures. That's the editor. You make when you want to do forms, this is an extension to the C language. You can put metadata in your class definitions, and then the form pop-up routine or the form routine will use these strings as the prompt for if you want to ask input data,